I want to welcome everyone to today's webinar series called Generative Entrepreneur. This is where we talk to our founders, our executives, and our developers to help them accelerate their generative AI applications to market and to deploy them to production at scale. Today's session is called Generative AIOps Playbook, and this is to help you unblock your POC workloads and move them into production. My name is Jason Virtue, and I'm a principal AI partner solution architect at Microsoft. I work within the GPS Americas division, and I help our partners both build and deploy production grade applications. In today's session, we'll be covering the Generative AI Ops Playbook. These will be our agenda items where we'll cover the lifecycle, the different tools you use when building out those applications. We'll do a demonstration for the majority of this webinar, and then we'll share the CI/CD pipeline so we can understand how we can deploy these to production. And lastly, we'll share with you a set of learning resources called the Generative AI Playbook. So hopefully that gives you a good idea of today's session. Let's jump into the life cycle and talk about its overall capabilities. What we really want you to understand is this is an agile workflow, and this model that you see in front of you is really a conceptual model. These different phases, the 4 phases that sit out there, is not an industry standard that's been developed by Microsoft or any other organization. We use this depiction to help you understand the workflow and help us showcase that user experience. In our previous session of the Generative AIOps Lifecycle, we went through the first 2 phases of this diagram, and that was prototype and development. In today's session, we'll really focus on the last 2 phases, and that's experimentation and production. In the experimentation phase, this is where our business users and our developers will come together in tandem to evaluate and achieve these 2 goals. One, they have the optimal configuration of this application, and it gives them the best performance. And 2, the best user experience. These will be the 2 things that we'll look at during experimentation phase. And what's going to be very important is scale. When we think about the number of test cases we have a lot of permutations of them. We have to look at, do we have the best model, the best indexes, the best model parameters, prompt techniques, or even data sources? And each one of these different iterations that we go through, we're going to have to automate both execution of our test scripts and the evaluation of those test scripts. So it's going to be very important. And I'll show you shortly how we'll automate that so we can scale. But once we achieve those 2 goals, then we're going to promote this application to production. And that's where the last phase comes in. We'll want to use different CI/CD processes such as GitHub Actions or Azure DevOps to deploy those applications to production. Those applications will not be deployed just once, but many times over time. So we'll want to make sure that we're following best practices when it comes to DevOps. And we want to make sure we're monitoring these applications. These applications will perform differently over time. Maybe performance or latency can pop up, or quality of our evaluations can start to deteriorate. And these will be things that we'll have set up monitoring tools for both our business users and our developers to go in and make changes as they need to. So that's an idea of the Generative AIOps lifecycle. And now let's go into that developer experience and do more of a show and tell to see how these work in action. So let's jump right in and show you how this looks like. We're in VS Code using the AI toolkit and the prompty extensions for us as a developer to start to execute our evaluations during the experimentation phase. In the previous phase, when we did development, we evaluated these models based on human judgment and did a manual evaluation. Those manual evaluations, we gave a thumbs up and down for passing. But when we go into experimentation phase, and if we want to scale, we're going to have to automate the evaluations and use what we call AI judges to do the actual model evaluation, both score them and give us a reason for the scores that they provide. And so what we'll do in this test script is we'll build a evaluate script that sits out there that will look at groundedness, relevance, coherence, and fluency. And we call these quality metrics. And so I'll run one set of quality metrics for my evaluations, another for safety, and the third for conversational simulation. So within my overall Python file, these are the metrics I'll look at. I'll connect into my project files so I can have access to large language models and my search index for my RAG architecture. I'll create a client that allow me to pass in my prompts, and then I'll go in and run my evaluations. I'll take my JSON data file. This is the data file that'll have both my queries, my context, my response, and my ground truth data. And I'll pass that into the model to evaluate it and also to write out the results and post those to AI Foundry. So let's go in and run this actual test script. We'll run our Python file and we'll show you those results. So after running my evaluation script, we can see in the actual CLI a set of responses that it provides to us, a set of calls to our models, and then at the very end, an overall score for both groundedness and relevance, and an individual score for each set of questions that we have out there. Now, as I said earlier, we post this to the AI Foundry. I'll show that to you, but let's first go through a new iteration. We're going to take this quality metric and look at it again, but what we want to do this time is add a new data source and change the overall system prompt. When we look at my prompty file, we can see my system message is a little bit complicated. So we're going to go in here and actually update that message so we have something that's a little bit more straightforward. Perfect. Now let's jump back in and kick off these results and show you how these will work. Now, we ran those quality metrics on our evaluation script. And if we drill in and we look at this in up close, we can see now those groundness scores have changed. We went from around a 1.6 to a 2.9, and our relevance score jumped up from about a 1.8 to a 3.3. And this is what I mean by automated evaluations. We can see now from each individual question that sits out there what the overall score was, and we can get a better sense for how our actual environment is performing. So, we've done our system test for quality. So now let's put our business user hat on and go into the AI Foundry to look at our evaluations when it comes to our quality metrics. If you recall, back in the development phase, we did a manual evaluation. And to give you a quick review of what we showcased was we went in and looked at every question, we looked at its response, and as a human, we gave it a thumbs up or thumbs down to see if we thought it was acceptable or not. As you can see, we got around 61%, which wasn't that great, but we were basically building out those assets. Now, if we have to do a thumbs up and thumbs down for all the different test cases we have, this will be a very elongated process. So as I talked about, we're using an AI judge when we talk about automated evaluations. And here, based on our last two runs, we can see with our quality metrics, the first one was using the elongated system message. And naturally, you would want that. You wouldn't probably shorten it in a real production scenario. We can see those scores were pretty low overall. We were getting about a 1.7 and a 1.6. We can also see the actual questions and each one of the different answers to those questions, along with those scores and a reason for those evaluations. But if we go back into the one that got the highest score, we can see we got about a 2.9 and 3.8. This was when we made the update to shorten that system message and, more importantly, also add new data sources. We can see my relevance increased substantially and the groundness improved also. Things are skewing to the right a little bit more than the left, so we're happy there. And if we quickly look at the data, we can see both the query that was sent into the large language model, the response, the AI judge's score from a 1 to 5, and the reason for that overall code. It's very important to understand why it actually gave that evaluation. We can see what the response was that we were expecting from the actual JSON file, the context or the search results, and the search results that came back from the large language model, along with the ground truth. And this will help us then evaluate our quality metrics. Now, let's transition and go back into the developer environment and show you some of the safety evaluation metrics that we have out there. From a safety perspective, now we're going to look at a different set of evaluation metrics. When we talk about safety, we really want to look at things such as the safety evaluations, which is an overall composite score, or individually, the sexual evaluator, the harm evaluator, the hate evaluator, or the violence. These are going to be the metrics we use to audit and to evaluate the actual large language models when it comes to safety. Now, in this particular evaluation script, we bring in the same project file that we had earlier so we can connect into our large language models and build out our RAG architecture. We create a project client that allows us to pass in our prompts, and we pull in the same JSON data file that we had before, and now we have a different set of metrics that sit out there. So let's run this and see what our results will look like. So let's look at the results for our safety evaluations that set out there. As you can see, this is a pretty robust JSON file, and probably me as a user showing you this out there won't be too useful, but I'll just show you one little metric that sits there. And we can see from a safety component, when we look at the sexual evaluation, it was a very low response for this particular question that sat out there, which was asking what was the capital, or is France in Europe? Now, let's go over and make this a little bit easier in the AI Foundry. I now, as that business user, is coming into the AI Foundry and looked at the quality metrics. Now I'm looking at the safety metrics. These metrics, as we said earlier, are a bit different than the previous ones. Now we're looking at violence, sexual content, self-harm, or hateful. And luckily, every one of these is showing a very low score. We can see from very low to high is our scale. And just like before, we can not just see the ratings, but we can also see the reason for those ratings. So very similar to quality metrics, we share what is the actual question, that we passed into a large language model, the response, the evaluation, the reason codes, and also our ground truth data. Now, this is the evaluation component that we spoke of. Let's finalize this with a simulated conversation. And this will be our last test script that we'll go through. Now, in our very last set of simulations that we're going to do, we're going to look at our evaluation scripts from a conversational perspective. We want to simulate that conversation and actually use our AI Foundry SDK and the simulator function to help create that. So like always, we create our project file, we create our AI client, we pass in our prompts to that, but now we need to talk about that conversational workflow. What type of question are we going to ask, and how many turns are we going to provide it? And we can see here in that actual conversational window, it asked what was the question, it gave me the response that came back, and then it asked a follow-up question. And we can go through this in multiple iterations, and through these actual simulations, start to evaluate what was the actual results from those particular pieces. So if I format this JSON file, we can see the overall question, the response that came back, the actual context, and get a sense for if those questions were acceptable or not. We can see the groundedness and evaluation that came back out of these for each one of those different questions. So this was our final test when it came to system testing. Let's now transition into user acceptance testing. Our business user has given us a thumbs up. We found a winner. We have now finished system testing, and we've realized what is our best set of models, prompt techniques, parameters, and data sources. So we finished system testing. We want now to move into user acceptance testing. And to do that, we first need to build out our CI/CD workflow. Now we need to start automating these different evaluations and do more online evaluations or evaluation through that CI/CD process. Now, depending upon how you've set up your environment, we've leveraged, in this example, AZD. And this is our Azure Developer CLI that allows us to automate the deployment of our Azure resources. So if we had a set of bicep files that sit in an infra folder, we would then be able to upload those into our Azure environment every time that we check in and check out our resources. Now, what I'll show you is that AZD command, AZD pipeline config, is what I will leverage to actually upload all of my environment variables into GitHub Actions. If I did an AZD up earlier, those Azure resources sit in the platform and it set up and configured my environment variables. This command now will upload those variables. For the CI/CD process, I will not be able to do a show and tell due to a pull request that disabled my environment, but I'll show you a few slides so you can get an understanding of that workflow. When we talk about us developers, we typically think about us developers building our own, say, feature branch or development branch on our local environments to make changes to our overall code set. As we start to ideate and explore that data, we'll then start to understand if we have a winner, as we did earlier in our system test environment, for the best set of models or prompt configurations. Once we do that, we can then start to merge that branch back to our main branch. And when we do this merge, we can do this across multiple environments. In our case, we were in our development environment, and we merged this over into our test environment. I'm calling this user acceptance testing, and that's where we can go for the next round of testings. So let's show you both that deploy and evaluate pipeline. Here, I'm using a repo called Contoso Creative Writer. This is a great repo that shows you that CI/CD process. As I said, unfortunately, my Contoso chat repo was broken, so I wasn't able to show it there. When we talk about the developer side of the house, now we want to automate that process. Every time I check in my overall code set, I want to rebuild that environment and deploy the new code that sits out there. So we can see through this build routine the set of steps that I'll go through to build out my overall Azure environment. But publishing that new code set isn't the only thing I should do. I should also go in and evaluate that code. And now when it comes to that evaluation, I have a set of evaluation steps that I can do, both unit testing and also evaluation tests that sit out there. So let's go in and see what that actually looks like. When we look at the evaluation summary, we can still bring in some test questions. We can evaluate it for its relevance, fluency, coherence, and groundedness, and look at my overall scores. Now here, we don't need a ton of questions, but we need enough to make sure that that deployment is done properly. And you can see, we can bring that into GitHub Actions and now automate that workflow. Now we're in our UAT environment. We have this on our local instance, and we now want to start to run our user acceptance testing. When we start to look at this environment, we want to make sure that we're testing the same type of things we did in system test to ensure we have consistency. So we'll go in now and look at both our quality, safety, and simulation evaluation results. I'm going to go through each one of these since you've seen it before, but I wanted to highlight one key component here. If we look at our actual test set or test cases, we have around 13 in this example. And this is a very important component. When we move into user acceptance testing, 13 is insufficient. What we really need to make sure is we have a representative sample of questions across all different types of questions we would expect when a user is using our application. Now, if we think about this website, we have different categories of products that sit out there. We have sleeping bags, we have shoes, we have shirts, we have tents, and we even have jackets. And each one of these categories probably have a different set of questions. So we'll want to make sure that we list these questions and make sure for each category we have a representative sample. But we also now need to think through within that category, what are some different type of questions? The ones we showed here were questions about what is the pricing or is it waterproof? But maybe now we're going to start asking questions that we'll see if the actual model will give it information that really doesn't know. So we might ask some questions that the model obviously doesn't understand. What is the capital of France? These will be things that we'll start to use in a much more robust set of quality, safety, and simulation tests so that we can ensure that when we bring it into production, we've tested a majority of those use cases. Now, we won't show you those simulations since you've seen them before, but these will be the types of tests. Now, where we want to head over is talking about load testing. The next set of UAT testing will be load testing. We need a load test our generative AI application for a few reasons. One, to see what the actual latency is for our end user to make sure that's acceptable. But two, also stress test that environment to see what is going to be the performance and if I need to start thinking about load balancing that environment. So load tests will be really one critical component. This I did not set up for a demo piece, but I will definitely refer you in the comments below to a session that Pamela Fox did on the reactor that shows us how to evaluate and monitor these environments. And when it came to monitoring the environment, they had a really nice simulation for load testing, which I'll share the link with you. Now, the last set of user test scripts that we'll go through is red teaming. Red teaming is a process where we'll have a set of humans actually start to test the safety and security of that application. Now, there's a tool that we can first use before we bring the red team in, and that's called Pyrite. And you can see the library that I have shared here and the link to that library. This is what we would use to automate some of those tests to make sure that our standard routines that sit out there are being tested for. And this will be a simulation that I do in a future session on security. But we also bring in our red teams to start asking those unknown questions just to see what might happen, or potentially to jailbreak our applications. These will be the different techniques that we'll have a set of humans do before we move it to that final phase, and that's in our production phase. Now we're in our production phase. And as I said earlier, we don't want to deploy that application and forget about it. We want to monitor it. And we'll have different types of monitoring tools that will sit out there. This one is a tool that we call a tracing tool. And this tracing tool is available in AI Foundry. And a business user can come in here and start to understand why it's getting the response that it's supposed to get. In this particular example, we're using a RAG-based architecture. And when we submit a prompt into my chat with products Python script, it's showing me what is happening. It's showing me what functions is inside of that actual Python script. And then it's showing what we submitted into the model. So you can see my system message and my examples. What was the actual user original question? And what the assistant said should be the search terms that we passed into the search engine. So the first one was kind of an assisted search agent. And here's what we'll pass into that search index. So we can see we need to embed that question. So when we do it into our vector database, we can pull back the best results. We'll pass in that question. We can see we got a 200 response, so that was good. That search response came back with the information. And now I can query that database with the products that sit out there. In the end, it'll return my search results back to me. And then I'll pass into the model again the set of documents. So here's my system message, right? You're a helpful AI assistant. The actual example, so it can provide further context. the actual user question. That was the original question that was asked, not the search question, but the user question, and then the overall response that came back. So it's recommending the trail master piece. So when we're in production and users might be complaining about different things that are happening with their application, this will be one way of tracing some of those responses to see how they happen. We typically would do this in the experimentation phase and not the production phase, but wanted to show that. If I do this in the actual production environment, I, as a developer, probably will not be using AI Foundry, but I can use App Insights. And through App Insights, I can see very similar trace logs that sit out there. This will give me the timeline so I can start to see when these things happen and what exactly happened within those files. So I can put this into a timeline now, and I'll bring this over there. What were the different steps in that overall routine? So you can see that same instance came back with the results. We can see us then going into the completions to embed those results that sit out there. And that same workflow came back. We can see some of the routines that came out. We can see the document search component that came back. And then lastly, the overall chat completion. So this is where we would do the tracing in production. Now let's transition to our monitoring tool, and then we'll go into our final component. In production, we're going to want to start to understand the overall performance of the application, both from a latency perspective, from a token perspective, from an overall quality and safety component. And so we have a dashboard that sits out there, an Azure workbook that's in preview right now that will give you the insights that you need in your generative AI application. And this is what we would use in production. We have a few in AI Foundry that you can use during your system test or UAT testing phases that will show you similar type of prompt information and quality metrics, but this is what we would use in production. As you can see, over the last 30 days, I've been pretty active in my token responses, and you can see a lot of queries being submitted and a lot of tokens for the inputs into those models, but my completions were much smaller. So the responses coming back were not as lengthy. And then lastly, you can see the total number of tokens and around the total number of calls. We can see when was my most active timeframes for the overall completions. And then we can also add, which I did not do in this workbook, the quality and safety metrics. So this is where we would, on an ongoing basis, be looking at the overall environment and also setting up alerts. Maybe if we pass a certain threshold when it comes to, say, prompt tokens, we want to be alerted, or we fall below a certain threshold for our safety metrics, we want to be alerted. This is where we would set that up so we can be proactive when monitoring these environments and ensure that we minimize the risk of our generative AI applications. There was a lot of content that we covered in today's sessions, and so I wanted to summarize this in a generative AI ops playbook and provide that to you as a learning resources. Also, I wanted to give credit to a lot of the Azure Cloud developer advocates that helped build this content, and you'll see the section within the GitHub repo that outlines that. So let's jump into this and just give you that summary so you understand some of the different content that's available to you. I've created a GitHub repo, and right now that's in my own personal GitHub repo, the data science and all environment. What I would love this to be is a generative AI cookbook where we provide you the best article from our community advocates on how to develop the generative AI application across the full life cycle. As I said originally, we want to do this playbook to help us deploy more applications from an MVP state over into production. And what we hope to do with this repo, and the reason why we set this up as a GitHub repo, is to help crowdsource this. So if you have any feedback you'd like to give us, set it up as an issue. If you have any suggestions, set that up as a pull request. We would love to keep this current as a living document as we move forward over time, because a lot of new things are happening. This is our V1 version where we're just focusing on the use case with what we at Microsoft call chat with your data, or others call chatbots. And when it comes to V-Next, we'll be expanding this for more advanced topics, things such as graph, RAG databases, or also jumping into things such as agents. So we really want to encourage you as our partners to leverage this as a learning asset so that both we can help accelerate your applications and you can quickly test and deploy those to production on a much more expedient fashion. So without further ado, I hope that was a good session for you. We want to thank you for listening to our two-part series today, and we hope to showcase and show you more capabilities in the future. Thank you and take care.